Hi everyone, welcome back to the channel. I am Kamal Krishna, and in today's video we are delving into chapter 1 computer exercises from Jeffrey Wooldridge's Introductory Econometrics using Google Colab. It is basically like Jupyter notebooks and it is super easy to use and perfect for econometrics. You can use any other coding platform you like. So let's begin. First, install all the necessary Python packages that we are going to use for this chapter. First, install Wooldridge and then statsmodels and then matplotlib, and then import these libraries. Import Wooldridge as Woo, import NumPy as NP, import pandas as PD, and then matplotlib.pyplot as PLT, and import statsmodels.formula.api as SMF, and then run this cell by clicking on this play button, or you can simply type in shortcut Ctrl plus Enter. Now wait for these libraries to get installed and import. Now let's begin with the first question. So this is the first question where we have to use wage 1 dataset. In this dataset, it is asking find the average education level in the sample, what are the lowest and highest years of education, and then find the average hourly wage in the sample, and then find the CPI consumer price index for the years 1976 and 2013, and then use the CPI values from part 3 to find the average hourly wage in 2013 dollars, and in the last, how many women are in the sample and how many men. So let's begin. So this is the cell where I have already programmed the commands. So let me make the output cell as a mirror so that we can see it side by side. So in the right hand side of the screen, you can see the output of this code, and in the left hand side, this is the code. So let's see. First, load the dataset wage 1. Type in the data frame by any name you can like, by any name you like. I'm using wage 1 equals to woo.data in the bracket wage 1, and then it is a good practice to know about your data set first before beginning to solve questions related to that data set. So type in the command print and in the bracket wage 1.head. It will give you first few rows of the data set. See, this is the result of this command. Okay. So it is displaying 5 rows from each column in the data set. Now type in print wage1.shape. It will give you the dimensions of the data set. Here are the dimensions 526, 24. So there are 526 rows and 24 columns. Now if you want to further explore, you can also type, to display column names, you can type print wage1.columns, and it will give you the column names. Here you can see, where is my mouse, and then you can also type print wage1.shape, and then use square bracket and then type 0. It will give you the number of rows, and if you want to get the number of columns, then you can type wage1.shape, and in the same square bracket you can type 1. Okay, so now let's begin with the questions. The first question is find the average education level, lowest and highest years of education. So create the variable average underscore edu and then wage 1, and then square bracket education column dot mean. It will give you the average. Similarly, create the variables for minimum and maximum. Minimum underscore edu and then wage 1, select the column educ education, and then dot min function. Similarly for max, you will do dot max function, and then type print f. See, f is a special string literal. It helps you to combine the string dataset and the variable dataset in one line. So print f and then then use quotes average years of education, and then curly brackets, type the variable name average edu colon, and then point to f indicates that we want the value to up to two decimal places. We want the value to be present here up to 2 decimal places. Similarly, then type print f lowest years of education, and then in the curly bracket min underscore edu, and then print highest years of education max underscore edu, and you will see the result here. See, average years of education is 12.56, lowest years of education is 0, and highest years of education is 18. Now it says find the average hourly wage. type a new variable name average underscore wage, and then select the wage column, then dot mean function, and then type print f average hourly wage in $1976, curly bracket average wage. Similarly, we want this value up to 2 decimal places. So now look at this right side. Average hourly wage in $1976 is 5.90. Okay. Now CPI values, consumer price index values for 1976 and 2013. I have acquired these values from online sources. For CPI 1976 is 56.9. Okay, and for 2013 it is 232.957. Now the question says convert 1976 wages to 2013 dollars. So what is the formula? We will multiply the wage column in the data set because it is from 1976. So we will multiply the wage column in the data set by CPI of 2013 and then divide that value by CPI 1976. So we will get the wages in terms of 2013 dollars. Okay, so first we have to create a new column. To create a new column, select wage one dataset and then square bracket, and in the quote you have to type the new column name. You can type wage underscore 2013 equals to wage 1, select the column wage, multiply by this value CPI 2013 divided by CPI 1976, and then take the average of this new column, average underscore wage underscore 2013 wage 1 wage 2013, and then mean function dot mean function, and then type print average hourly wage in 2013 dollars, and then the variable name in curly brackets. So you can see that average hourly wage in 2013 dollars is $24.14. Now the question says the count number of women and men in the sample. Create a new variable number num underscore women and then use round bracket. Okay, type the dataset name wage 1 and then square bracket, select the female column. If the female column is 1, it means that it represents the female variable, female respondent, and if it is 0, then it is a male respondent. So first we are counting the number of women, that's why it is equal to 1 and then dot sum. It will give you the number of women, and then type the variable number underscore men, and then same formula, just type here 0 for men and then dot sum function. Now type print f in the quotes number of women in the sample, type in the curly brackets the variable number of women, and then type number of men in the sample. Similarly in the curly brackets type number of men, num underscore men. So number of women in the sample is 252 and number of men in the sample is 274. Now let's look at the second question. Okay, so in the second question we are using birth weight database BWGST, its birth weight. So first question says how many women are in the sample, how many report smoking during pregnancy. So and the second question is what is the average number of cigarettes smoked per day? Is the average a good measure of the typical women in this case? And then among women who smoked during pregnancy, what is the average number of cigarettes smoked per day? How does this compare with your answer from part 2 and why? And find the average of father education in the sample. Why are only 1192 observations used to compute this average? And report the average family income and its standard deviation in dollars. So first, load the dataset, create a data frame BWGST equals to wo.data, and then in the bracket BWGST. Okay, so the dataset has been loaded. And to know about your dataset, type print bwgst.head, and you can also type print bwgst.info. So this first command print bwgst.head gives you this first five rows from each column, and if you type print bwgst.info, it will give you this answer. So there are total 14 columns and 1388 entries. Okay, so let's begin. Count total women and those who smoke during pregnancy. So simply create a variable num underscore women, type the dataset name dot shape, and then type 0 in the square bracket. It will give you number of observations and women in, that is women in the sample. All the observations in this dataset are from women. Therefore, the answer is 138 as we saw in the earlier command. And number of smokers, for number of smokers, we will select the sixth column CIGS, okay, and it should be greater than 0. The column 6 represents the number of cigarettes smoked per day. So if it is 0, then we will be able to count women who smoke during pregnancy. So this column value should be greater than 0, and then type sum function. It will give you the number of women who smoke during pregnancy, and you can see the result. So you can see total number of women in the sample is 138. Look at the right hand side, and then below this you can see the number of women who smoke during pregnancy, 212. So it's a very small number. Now coming to the second question, calculate the average number of cigarettes smoked per day. To create a variable average underscore 6, select the 6 column and then mean function. It will give you the average number of cigarettes smoked per day. So let's look at the answer. So it is 2.09. Now the question also says whether the average is a good measure. Well, so what do you think? See, the average may not be a good measure because many women do not smoke, making the mean misleading. Okay. So now coming to the third question, it says average number of cigarettes per day among smokers only. So first we have to select only those observations which have the value greater than 0 in the column CIGS 6, and then take that average. So for this, select the data set BWGST, then type square bracket, and then again BWGST, and then again square bracket, type the columns name 6 equals to greater than 0, okay, and then close this bracket, and then start a new square bracket, type the column name CIGS 6, and then after closing this bracket, type the mean function. It will give you the average cigarettes per day only among smokers. So what is the answer of this? So average cigarettes per day among smokers is 13.67. It's quite high. It is almost a packet. So now let's look at the fourth question. Find the average father's education level. Simply type the new variable average underscore father education, type the dataset name, then type the column name, and then use mean function. And it says we also have to count non-missing observations. For this, select the column name again, father education, and then type count function. So average father's education level is 13.19. Okay, and number of observations used for father education is 1192. Okay, because these observations are non-missing. Okay, so only the count function counts the number of rows which have some value. Okay, it ignores non-missing observations. It ignores missing observations. Okay, so that's why we use only 1192 observations in the average. Now the fifth question says report average family income and standard deviation in dollars. For this, create a new variable average underscore family income. Use the column name family income dot mean, and then convert to dollars, and then type into 1000 because we are converting this value into dollars, and then type new variable standard underscore family income BWGST. Use the column name family income and type the function std. It will give you standard deviation of this column, and also then type into 1000. It will be converted to dollars. So what is the answer of average family income? Is $29,026, $29,026, and standard deviation of family income is 18,739. Okay, so now let's move on to the third question. The third question, we are using the data set MEAP, MEAP 01. So it represents the state of Michigan in the year 2001. So let's look at the questions. So let's first load the data set. MEAP01 equals to who.data MEAP01. Then type print MEAP01.head. It will give you these values. So in total there are 12 columns. Okay. Now the first question is find the largest and smallest values of math4. Type in the variable max underscore math4. Type the dataset name. Select the column math4. Type max function. And similarly for minimum, type the variable minimum underscore math4. Use the dataset name. Then use the column name. Then dot min function. And this will give you, for range, you can use the formula maximum math4 minus minimum math4. Okay, so it will give you largest, smallest, and range of this column math4. So what is the answer? Largest value of math4 is 100, smallest value of math4 is 0. So range of math4 is 100. And now let's look at the second question. It says count schools with a perfect pass rate in math. So we have to count those values where math4 is equal to 100. So let's create a variable perfect underscore pass math. Then type the dataset name, then type the dataset name again, and then select the column name math4 equals to 100, and then type dot shape in the square bracket 0. So this formula, this command will help you calculate the number of responses in math4 where it is 100. Okay, and for total schools you can type MEAP1 dot shape in the square bracket 0. And then for percentage perfect pass rate, we can use this formula. Type in the variable perfect pass math divided by total schools into 100. So let's look at the answer. Number of schools with a perfect pass rate in math is 38. Percentage of, when it is the percentage, and in percentage terms, it is only 2.08%. Now look at the third question. It says count schools with a 50% pass rate in math. So similarly, earlier we had used 100 to find perfect pass rate. This time we have to use 50 instead of 100, and then type in the same formula. So what is the answer of this? We can see that number of schools with a 50% pass rate in math is 17. Now we have to compare average pass rates in math and reading. Simply select the dataset name and then the column we are interested in, math4, and then type in the mean function. And for the read4 function, similarly we follow the same process. Type in the new variable average read4, select the dataset name, then data column, and then mean function. So average math pass rate is 71.91%, and average reading pass rate is 60.06. So at least in the state of Michigan in 2001, people were scoring more in math than reading. Now we have to calculate correlation between math4 and read4. Type in the new variable correlation equals to MEAP01 and then select these columns. Okay, math4 and read4, and then type core function, CORR, core function, and then type ILOC square bracket 0,1. We are using this command ILOC to give us specific value which is present in the first row, second column. If we do not use this command, it will give us the whole correlation matrix. Okay, so now type print correlation between math4 and read4 column in the curly brackets this variable correlation, and now let's look at the correlation value. The correlation between math4 and read4 is 0.8427. That is 84.27. It's quite high. Okay, so you can see this command. If correlation is greater than 0.7, print there is a strong positive correlation between math and reading source. Okay, now let's move on to the next question. Sixth question is compute the average and standard deviation of expenditure per pupil, and this is represented by the column EXPPP. So create a new variable average underscore EXPPP and select the dataset, and then select this column EXPPP. Type the mean function. For standard deviation, type std underscore EXPPP. Select the dataset, select this column, and then type STD. So this represents standard deviation. And then type average expenditure per pupil, and then type standard deviation of expenditure per pupil. So what is this? What is the answer of this values? Average expenditure per pupil is $5,000, $5,194, and standard deviation of expenditure per pupil is $1,091. So standard deviation, let's look at this. If standard deviation is greater than 0.2 of average expenditure, that is more than 20% of average expenditure, then there is wide variation in per pupil spending. And if it is less than this 20%, then there is not much variation in per pupil spending. So standard deviation is almost 20% of this average expenditure. So there is wide variation in per pupil spending. Now look at the last question. It says compute percentage difference in spending between school A and school B. So in the question it is given that the school A spending is $6,000 and school B spending is $5,500. So simply we have to compute the percentage difference. For this, create a variable percentage underscore diff, and then select school A spending minus school B spending divided by school B spending into 100. This will give us the percentage. And to check the log approximation method, we are going to take log of both of these values and then take a difference of the log of these values and type and then multiply into 100. Okay, so let's look at these values. First we have the percentage difference method. It gives us 9.09%, and when we take the difference of the log of these values, we have the answer 8.70%. Okay, so what happened? We know how to calculate percentage difference between these two values. Okay, now to show that the log, when we take the log of two values and take a difference between them, it will approximately give us the percentage difference between these two values. And for taking log, we have used this function np.log, then type this school A spending minus np.log, then the school B spending value, and then multiply it by 100. It will give us the percentage difference. Okay, so this question is done. Let's move on to the next question. So in the fourth question, we are using the dataset JTrain True, and it comes from a job training experiment conducted for low income men during 1976 to 77. There are four parts of this question. In the first part, it says use the indicator variable train to determine the fraction of men receiving job training. It means that the train variable is a binary variable. There are only two values in this column, 0 and 1. 0 indicates that men have not received training, and 1 indicates that a man has received training. Okay, so let's start with the first part. First, load the dataset JTrain2 equals to woo.data in the bracket JTrain2, and then click this button to display the first few rows of the dataset. So these are the columns of this dataset. Now the first part is fraction of men receiving job training. So first we have to calculate the values which have we have to calculate the respondents. We have to sum up the respondents who have received training. So simply type JTrain, the dataset name, in the square bracket type the column name train equals to 1 dot sum function. So this will give us the value of men who have received training, that is 185. But this is not the full answer. We have to calculate the fraction. So divide this sum by the total number of rows of the dataset. So we can type JTrain2 dot shape square bracket 0. So this value is being divided by the total number of rows in this dataset, and then type and then click this button or simply press Ctrl plus Enter. So this is the answer. Fraction of men receiving job training 0.41, that is 40% of the men have received training according to this dataset. Now average earnings in 1978 is represented by RE78 for trained and non-trained individuals. So create a variable average underscore re78 underscore train, type the dataset name, and then type the dataset name again. Select this column train equals to 1. So this represents the men who have received training, and then in the square bracket type re78, which represents average earnings, and then type mean function. Similarly, for not trained men, we have to type here in this the train variable, the train column is equals to 0, and then type the mean function, and then we have to calculate the difference between the average earnings of those men who have received training and not training. So average 1978 earnings for trained men is $6,349, and average 1978 earnings for not trained individuals is $4,554, and the difference in earnings is almost $1,794. So the difference is economically large, suggesting job training increased earnings. Now, in the third part, we have to calculate the fraction of men unemployed in 1978 for both trained and non-trained individuals. And unemployment is represented by un-78 column in this dataset. So like we did in the earlier question, similarly type the dataset name and then type the dataset name again to select this column train, okay, equals to 1 for trained individuals, and then type the column name un-78 and calculate the mean for trained individuals. And for non-trained individuals, here you have to type 0 instead of 1 and then do the similar procedure. So what is the fraction of men unemployed? See, those men who were trained and were unemployed in 1978 is equals to 0.24. Okay, 24% of the men who were trained are unemployed in 1978, and 35% of the men who were not trained were unemployed in 1978. So trained individuals had a lower unemployment rate, suggesting job training helped employment. Now in the last question, it is said, was the job training program effective? So how can we judge this? We can judge this on the basis of earnings and unemployment. So in the difference, if the difference in earnings is greater than 1 and unemployment of trained individuals is less than the non-trained individuals unemployed, so we can say that yes, the job training program was effective. So look at the answer. The job training program seems effective as earnings increased and unemployment decreased. Okay, so this question is done. Thanks for watching. If you found this helpful, don't forget to like the video and subscribe to the channel for more content like this. See you in the next one.